This is a recording of a live demo that shows how to model steel structures and generate shop drawings in Parabuild.
I will begin demoing Parabuild inside BricsCAD. Some of you may know already, some of you may not know yet. So the trial version of Parabuild contains exercises, and those exercises are ideal if you want to start learning Parabuild. Those exercises, they contain a lot of on the topic of creating macros and context modeling. For this reason, I would like to start with something a bit different. I would like to draw something without too many macros, and we would call it basic unconstrained geometry. So let us start with drawing a simple rectangle. And this will be a simple structure. It could be, for example, a fence or a door. So let me quickly lay out the framing. So I've assembled some lines here, and now I can use the Parabuild library to draw some hollow sections on that. So we can just select a number of lines, and on each line Parabuild then draws a profile on top of it. Let me switch to a better visual style so that you can see what I've just drawn. So let me start off with creating miters here at each corner. So there's a command for miters. If you've already used Parabuild and you see some small changes, then that's because I'm using a newer beta version than you are using, so this is coming to you really soon. So those are the miter connections, right? So I still need to solve this collision, and there's a different kind of command for that. And I'd like to show you. So normally we would use one of these two to get one part to another part. But what is the difference between the two? Because the icon looks almost the same. So by way of example, I'm going to show the difference. This command will only shorten the profile, whereas this command will shorten and or extend the part. So to show that, I'm going to quickly shorten that just for the example. And then let me cut this part against that one. This does nothing because I've used a command that does not extend. So let me use that other command. And this command does extend up to the other part. So I'm going to use the same tool to do the same for the other profiles. So I did one cut, and now I can do the other. So that completes that connection. And here I can just select the three together. Okay, so those cuts are done. And I'd like to show you some ways to draw bolts. Here you have a single bolt. Yeah, I'm sorry, I am used to the toolbars, but there's a ribbon which contains the same command, so I'll try to use a ribbon once in a while. So here you have one single bolt, just select the part that should receive bolt, and you can draw a bolt there, but the downside of this tool is that you need the exact coordinates. So this is not necessarily the best tool in all circumstances. So for that, there is here a very practical tool, bolts on a plane. And if I just select this side face of that SHS profile, it now proposes two methods for drawing bolts on that face. I will show both. So I will start first, use this large plane to draw the pattern on. So it just did what I asked. It uses the circumference of that plane and draws bolts on that. And I could, change the assembly, change the diameter, and change the number of bolts. So this is a macro drawing for me based solely on that plane. Okay, I can use the same tool here on the other side. So I'm going deeper and selecting the back face of that SHS. And now I'm going to use the first option. So this option allows me to draw a bolt somewhere locally, not spread over the entire surface. And to do that, I need to select a face or an edge that will intersect with, that will then be intersected with the first plane that I selected, and that will determine the position of the new bolts. So let me show you how that's done. And we could as well just go to advanced here and start activating things like slot holes. So as you can see here, I activated slot holes. So if I do it in a macro, then I am doing that for all of the bolts and holes in that macro. So that's speed up. That's can speed up my work, I mean. But say in case that we do not have a macro, like here, these are single bolts drawn manually. So here, I could as well just activate slot holes, as you can see, or I can go back and I could activate threaded holes. And so activate threaded and then maybe deactivate nut. So if you look close, you can see the threaded lines in there. So having the macro speeds up our drawing, but it's not necessary. You can always fall back to the other basic modeling tools in Parabuild, and of course the properties panel is very important in that regard. There are many properties for all of the objects in Parabuild. The next thing I'd like to show you is welding. So welding can be done here. Just select all of the subparts and then select the main parts. And you can see by the coloring, all of the parts that are blue are subparts, and the main part will keep its normal color. But there is a tool for knowing which part is welded to which assembly. So this assembly selection tool, if I now hover over one of these parts, it highlights the entire assembly so that you can review your assemblies in the drawing. And if you then disable that, then you have single object selection. Something else I'd like to show. So if I now select this main part and I would stretch it out, you can see that immediately these macros will respond to that change, and they recalculated the cuts, and here this the bolts and the cut was recalculated. So what happens if I would delete the macros here, and I would do the same? Then nothing happens. So without the macros, all the Parabuild objects will react a bit like they would, a bit like you would expect from standard AutoCAD or BricsCAD objects. So you are always in control which part should be intelligent of your drawing and which 3D parts should be basic static objects. Okay, I'd like to show something else now. Let me start a new drawing for that. I have drawn some hollow sections here, and I used the profile library icons for that. And you can see here a lot of shapes here. So each of these here represents a table, and then you have the list of entries inside that table. And then here you have all the categories of standard sections that were added. But say, for example, there is one missing here. You may need a 6060 by another thickness 8, for example. You can just click on Add Quickly and then add the parameter that you would need, and that will just add it to the list here. Now, say that in case perhaps this list here is too large, you want to hide some profiles, or maybe you're looking for another section that's missing here. You can just click on Edit Library here, and then go to Overview tab. And here, this is the full list of all the tables in the library. So each row is a table, and they are sorted on the type. So first I shapes, then C shapes and angles. So you can browse through them and see if there's anything you could use. And in the metric column, you can activate those tables that you want. And then the imperial column, that's only valid if you are working in an imperial drawing file. So everything that you deactivate or activate here will be reflected in this dialog box. Okay, so that's that. But what happens in case you have another shape that's not even in those tables? So maybe it's a fully custom shape that you need to draw. And so for that, to show that this is still possible, I'll draw a simple roof gutter. So I'm drawing a polyline, and I'm going to quickly sketch something. So that is just the circumference, but I need to offset it. I need to give it thickness. And then I still need to close up polyline. And then I need to join it into one polyline. If I'm going too fast, well, then don't worry. We will send everyone recording after the demo. So then you might want to review everything that I've done. And I've used the command line a lot. That can speed up the process. So it's not closed here, but that's not bad. Parabuild will close the last segment always. So the command for saving that to the library is here. Add to custom shapes library. So I'll just call it webinar. And then select polyline. and that should have saved it in library. And let's see, with this icon, we can open the custom shapes library. And then let's go to webinar. This is the polyline. And if I just attempt to draw that, you will see that this is the section that I just sketched. And this is just the main profile in Parabuild, so you can use all the basic modeling commands on them. So if I would use a single bolt command on this, that just works. Even this bolt on a plane macro will work. Just select the face. So these commands do not have any assumptions about the shapes that you are selecting, so that's why they will work on any custom shape. Okay, so I'll move on to the next topic. I'd like to show something and start with context modeling. And I'm going to draw a portal frame building, and in that case it's best to have the grid lines drawn. And if we start drawing on the grid line, the default height of a column will be 5,000. That's of course not what I want to do right now. Let me quickly create two levels. So the first one at 4 meters, and then the second one at 8 meters. So I want the top of the column on the level 2, and then the bottom just to the floor. And I'll quickly draw some columns. I'm not going to go into detail with the context modeler because of the exercises already explain a lot about them. So now, as you can see, the height is based on the world. So it's better to use the magnet in that case. And now you can see here at the right, 0. That means I've fixed it to the level 2. Okay. So that's the portal frame. Now I'd like to draw a simple platform here inside. So I'd like to fix that to level 1. Okay. Let me switch to a better view. Okay. I'm going to draw some connections now. So I start out with base plates. And I can use propagate to repeat that same base plate for all of the other columns. And I could say I need 6 bolts instead of just 4. Let me look at some other connections. Let's see this one for this case. Then the next connection. So that solves that situation. Now I can propagate that. As you can see, it has made 6 copies. This one is not yet connected. I forgot to propagate that, so I can just double-click the plate and then say propagate. And that should do the copy. Yeah, but it didn't. It did something that I didn't want. So let me remove that connection. Okay, I'd like to, have the beam seated on top of the column. So let's look at the icons here for that. There is one icon here that looks a lot like this situation, so I could use that. But what, there is a connection for this, but it's not exactly the situation that I wanted to do. So let me rotate this like that. Yeah, this is the situation that I wanted to do. So let me retry then. Okay, so I just wanted to have an end plate, but what in a case where the beam would be a custom shape and Parabuild doesn't know about that shape, so there is no connection for that. Well, in that case, if you only need an end plate, then you're always lucky, because there is a tool to draw an end plate. Just use a baseplate end plate icon, and then use this end plate to plane. There is also to point, but to plane is always better. And then just select the face to which the end plate should be attached. So I'm selecting the bottom face of the beam, and that's it. So with this tool, you could draw that end plate to any profile, even unknown profiles for which there are no connections. Okay, then something else here. Here we could use one of these connections here. So, okay, I could use this one, but I'd like, for this demo, I'd like to show that these macros here are modifiable, because each drawing that each example that you see here reflects a DWG file. So what I'm going to do now, I'm going to open this medium moment connection. I'm going to do some modifications to it, and then try to use it in this, come back to this 3D drawing and try to use that newly created connection. So let me open up the Parabuild library. So the Parabuild library is always by default the Parabuild folder and then the pblib folder, and I'm looking for a macro, and the one that I need is in this folder. So I know this because there is a link between most icons in Parabuild. There is a link to a folder in this directory. Okay, let's look at the drawings here, and this is the one, medium moment. This is the one that I'd like to modify. Okay, so what if this beam is much larger? So let's take 550. Okay, I did a wrong click there. Let me retry that. Yeah. And what if the beam then is also larger? So we would need a wider end plate and maybe some more bolts. And for this situation, just for the example, we would need more stiffeners. So let me add some stiffeners here. And I'm going to add these small stiffeners. Again, we can use plane, so this will work on any shape, profile shape, this tool. And at the top, same. I am using the top face, so that face will be projected to my column for the position of the stiffener. This drawing, you can see that the beam is drawn at an sloped and such, but Normally that's not the case, but this is just done quite often in the library just to test the macro that it would work in such a situation, but that doesn't mean that it's a common situation. Okay, so I now have 3 macros, but I'd like to merge these together, because if I would open up this macro, I do not see the stiffeners here, so it would be better to have that merged. So there's a merge command, and I want to merge this macro with the other 2. And so you can see already here that it gets a new tab in the same dialog box, and there's 1 sphere only. Okay, and then that's done. We can save that in the library, and I'll call it webinar connection. Close that. And now I return to my drawing, and I will now insert the connection that I just created. So while doing that command, it analyzes all the DWG files in the folder, and it only shows those that are compatible for the 2 profiles that I selected. And this is the new webinar connection that I just created. So I can just insert that. You can see these are the stiffeners, and I can then propagate that to the other 3 beams. Okay, so that was about the macros, and I would now like to do some more advanced macros like bracing and stairs, but I will now save this drawing in BricsCAD, and let me save it in the webinar folder. Let me call it demo. I'm going to close this, and I'm going to open up the same drawing in AutoCAD just to show that Parabuild is cross-platform, and that, you know, it's quite similar to work in Parabuild on the 2 platforms. And you will see that when I continue working on the same drawing here. Okay, so the next thing I like to show you is bracings. Angle bracings. I'd like to add them here in the roof. The bracing command is really just a command that helps you inserting several macros at the same time without having to do all the manual clicking. So that's why it's proposing asking for the gusset plates after drawing the cross. So this is the bracing macro. I can just propagate that, and that should propagate it to all the other rafters, and I could do a change. So that's just an example. Another way to draw a bracing is by limiting the extent. So what I'd like to do, I am using this tool here. I want to fix the top side to a member. So I want to draw it between these 2 columns, and I want this member to limit the height of the bracing. So that's the same as before, same tool, and I can propagate that, and that'll only propagate to the other side, because here we have this different situation. The beams, the columns are not as large at all, and we have different orientation. So that's why the propagate doesn't do the copy. Okay, then I'd like to show a stair example. So a command for it. Let's see here, stair. I'd like to start the stair here, and then run to the floor, and the location should be against the wall. Okay, so we can do some modifications here. This is a type of thread. There are other types of stairs. You can draw stairs between two profiles or just on a line that you've drawn manually. And then I'd like to start drawing some railings. So it's better to select an edge on a profile. It's always the best method, if that's any way possible. And I'm not going to draw it from here to there, but I'm going to draw it to there. So that's why I need to select a intersection geometry, and this is where the railing will stop. So you can see that those intersection tools like that you saw for the bolts, it's the same thing that we can do here for the railing. So that's the second segment, and then another segment here at the end. So the last segment that you draw will be attempted to connect to the previous segment. And then if you end the command, then it should close up the open endings of the railing. Okay, here you can see it will just center the railing on the edge that I selected. So I'm going to, you can choose, of course, move it outside profile or on top. So I'm going to move them on top of the profile. And I'm going to connect these to the stringer. Okay, I just made one of them, but with propagate, it'll just do all the others immediately, but it does not do the copy here because that's a different connection. Not only the shape is different, but the slope of the post is I mean, of the stringer or beam is different. So that's why the propagate refuses to simply do the copy. Okay, just create one, do propagate, and that should take care of the rest here. Okay. Now that I've done some, drawn some things on top of these beams, I'd like to now change the level of these beams. So let me open up the context modeler and then go to the levels. So the level 1 was 4 meters, and let me change it to 5. So what happens, these beams were fixed to the level 1, so they move upwards, and as a result of that, the bracings will follow because I've selected that beam for the bracings. And then of course the railing and the stair will follow as well because I have been selecting those edges of these profiles, and thanks to that we can keep these parts connected to each other. But each of these things is always determined by a macro, so you can start deleting macros if you don't want the behavior for a certain object. One other thing I'd like to show is the grating. So here we have grating threads. It already automatically drew some gratings, but we can also draw them manually. So here in the library, we have under the floors, several types of grating. So here you can see the list. This list was created by Malcolm. So it's just a general list of what should be common in the world. But in case you have a manufacturer with other patterns, you can just click add quickly. And here you can see all of the parameters. So the total width of the panel, height, and the bar thickness and such, all the data needed to draw that grading panel. So let's just draw one. So this is actually, what you see here is actually just one of the profiles of Parabuild. So that means you can use cutting commands like these here. You can use all of these on them. So that's a big advantage. But in this case, all of the details are drawn. So in a large drawing, that might create too much clutter or might cause some performance hit if you have drawn a lot of grading. So there is a tool in the visibility manager that was showing up on the wrong screen. And here, if you look here at the bottom, grading visibility, you can change that to symbol, for example, or that could be a hatch, simple hatch. So you can, remove the clutter if that's necessary. But here you can see actually what it is. It's a profile, but with additional grading data added to it. Okay. So this structure is already a lot of intelligence inside it, but we can still go a little further. And let me open a sample drawing for that. So this drawing, it's a template drawing of a fully constrained portal frame. And you can see here, everything was drawn. So connections were drawn, but also purlins here, and then cladding from first to last portal frame. So if we then modify the general dimensions of this portal frame, then all of the rest will follow. So let me change that to 50 meters. And then change the number of portal frames. And I could as well just change the apex height. So how this works is we have the basic portal frame, and then we have an array object that arrays that portal frame. So that's the number 10 that I entered here. But because the template drawing contained a lot of connections between those portal frames, like the purlins and the cladding sheets, the macro system just takes care of that. It analyzes the connections between the portal frames, and it fixes the relations, adds copies or removes copies if needed. And yeah, you can have a fully dynamic template drawing like this. And we have other examples. There are some on YouTube for transmission tower, and there is also a stair, cage stair example. So yeah, look at that if this is of interest to you. Okay. The next thing I'd like to now start with talking about the document generation. So let me open up the Sheets Manager. You can also find that here, Sheets Manager. And then if you look here at the top, you can just double click on one of the bill of materials, and that'll open up the bill immediately. So just quickly showing some bills. But if you need a change, you can just right click and then say modify settings. And here you can just add more columns to it here, activating here, or change the sorting here. There's lots of tools. So if you would need it. You can find it there. And if you need another type of build, here is a tool for showing up the hidden builds. Okay, I'm now going to start generating some single part drawings. But as you can see here, so at the top, we saw the list of all the builds, but here at the bottom, you can see a list of all the parts in the drawing. But this is actually the bridge between 2D and 3D. So the step, we regard it as a step towards document generation. So we have the 3D models, and Parabuild assigns numbers to each models, but if it encounters identical parts, it will assign them the same part number. So here you can see A3, there are total 9 parts of them. So that's what Parabuild has found to be identical. So the same thing, so we are looking now at the assemblies, but the same thing is true for single part numbers. So this numbering is done automatically for you on demand when you are requesting a shop drawing or a bill of material. This is done for you in the background immediately, and you don't need to work on it or know much about it unless if you want to configure it, of course. So this, if I click on positions, these are the position parts. So here you can see 15 of PL1, and yeah, those are all the parts. So if I could want to know PR9 CHS, I can just right click and then say select all parts, and then it'll highlight all of those parts that Parabuild has assigned that number to. So that's this way it makes sense that this is the first step towards document generation. And so after generating the shop drawings, you can now see the sheets here at the top, and we can just double click that, and that'll open up that sheet. So it has generated a drawing or a view per part number. So for the plates, you can see that multiple plates per page is enabled. If you do not want that, if you can disable that, just go to settings, and then here we have to go to plates, and then automatic generation of sheets, and this checkbox, allow multiple parts. If you disable that, then you will get 1 plate per sheet. Let me browse through some profiles here. So this is one of the stringers. So all of the holes and cuts have been dimensioned. And this is the other stringer that has those post connections. Okay, so these are quite straightforward, but assemblies, it's always a bit more difficult. So I'd like to show something about the assembly drawings. So let me open up the properties. And I'd like to generate the assembly drawing of this column. Okay. So we have 2 side views, and then an end plate view, and then this left view, or whatever you would call it. And as you can see, these are aligned. So this is following the strict projection rules. And here, this is a column, yet the view is drawn flat. But we can configure all of that. So if we go to settings, and then assemblies, here you can already see which type of projection you would like, the first angle or third angle. But here with the pre-configure button, there's more interesting stuff to see. So here, align column 3D view with the model Z. So this means draw column 3D view upright, really. And something else here, we can play around with maximum and minimum number of views. So if I say 3 for both of them, then you will see 3 views, 3 side views. So let me regenerate assembly 5 so that you can see the difference. So these are 3 views, and then the column is down here. And probably because of I've activated 3 views, we now have a different format. And yeah, because it's taking up more space. If you're wondering how that works exactly, well, it's just a list of pages and scales that Parabuild is allowed to use. So if we go to assemblies and then automatic generation, in this list you see all of the formats and scale combinations that Parabuild is allowed to use. So you can add more scales here because you can see that it switches from 110 to 112. You could put 111 in there. So yeah, you can play around with this, remove formats from it. I have seen people using A3 maximum and then just removing A2 and A1, A0 I mean, and then just adding A3 with much larger scales. Okay, I'd like to explain some more about the options here. You can see here this viewing direction for the section A. It's from inside part to the outside. So that's why the eye shape is drawn in full and not hidden. And I'd like to switch that. And I'd also like to, this is taking up a lot of space, these views together. So I'd like to enable more free location for these views. So if we go again to the pre-configure setting, I'll go back to 2 views, and then this here allow views location to be free. That's what I'd like to do, and then view the section views from outside to inside. And let's try that on the same assembly to see the difference. Okay, so you can see now that the strict projection rules are ignored now, for at least for these 2 views. Yeah, maybe here this is still aligned, so maybe that is still correct. But yeah, this causes again a smaller format to be used for this part. And so yeah, this is how it looks if you generate the drawings out of the box. One last thing I'd like to show, and I want to generate another drawing for that, another assembly for that. So I'd like to generate the drawing of this beam. Okay, so this is a rather simple assembly. It just has a few end plates, but you can see here that it will automatically add some orientation dimensions, as we call it. So these dimensions are solely, the purpose is solely for the welder to check that he's looking looking at the part correctly, so that he can check yeah, if his orientation of the part is correct before he starts welding it. But you can disable that, of course, if you go to Settings and then Default Dimensions. Here you can see two options that are of importance. Section View, that is for this view here. So if you look at this, so that's quite straightforward. A lot of options here for adding or removing dimensions to it. And then you have the side view settings. And here I'd like to show you the orientation dimensions. So for the main part, this is the default if confusion is possible, but you could say always all of the dimensions. So then you would have enough dimensions to produce that main part. Or if you say never, then it will not show anything. So the same options are available for subparts, but this is just additional dimensions if you want to tweak a bit with the default normal dimensions, then you can find them here. So base dimensions, that's the ordinates, and chain dimensions, and then local dimensions, those are usually local to the axis of a profile, or you know, like you see here in this example, for the size of the part. Okay, so let me show you the same assembly, but now with the orientation dimensions disabled. And as you can see now, all of them are gone, and only the dimensions needed to weld the parts together are shown. So that's just, you know, I want to show that because it's a rather important option. And what I have been doing here, creating 3 times A5 and 2 times A12 is not okay. So it's just for testing. There should be here just one A12 and one A5. Otherwise, you might print duplicate shop drawings. So yeah, that was just for testing. This is how it should look. Okay, then other things on the sheet can be configured, like here, for example, this title. Could add the logo here of the company, or we could play around with the columns, add more columns, remove columns from it. Or here, this bill, this is an additional bill for the bolts. You could remove this bill. So this will show all of the bolts that are assigned to this assembly, but also shop bolts will be shown in this list here. So the location to configure that is under assemblies and then settings for page and layout. And here you can see that all of these templates, so layer, which layer should be used, which dimension styles, which build template, and then the secondary build template. So you can switch the templates here, or just delete it if you do not want a secondary build template. And if you're wondering where does Parabuild find all of these template drawings, I'll show you the folder for that. Yeah, I started a new drawing. I want to open up the Parabuild library again, and here the workshop drawings folder, and here you will see builds, dimension styles. So this is a reflection of what you saw in the dialog box. Each type of template, there will be a folder here, and then title templates. Here you can see English. You can just open this up, insert a logo in it, remove properties from it, and yeah, start using that. Okay, then I'd like to continue with showing some options for the Cnc files. So here you can see Dxf and Dsv. So Dxf, that's for plates only. And if you start generating here, if you look at Dxf Settings, the most important option here is welded plate part contours. If this is enabled, then you will get more Dxf files. And if you disable it, you will get less. But the advantage of enabling it is that you will get contours added to the plates, and that's easier for welders having to measure less. And then the same is true for the Dsv files. There is the Dsv Settings button once you start generating. And here you can see welded part contour options. So if we start activating contours, then you will get more CNC files, but with the advantage that you will get IKEA parts that can be assembled without much having to look at the drawings. So let's generate these drawings. So you can see here at the bottom that it has generated. So let's look at the Dsv files. So you can see here everything that I've generated. Let's find some interesting file here, PR2. So I'm opening this up in ProCam, which is the STV viewer. And as you can see here, this is how it looks. So you can see here, it should, this is the bottom of the stringer. It's a bit hard. Yeah, that's how it should look. So this is just where that footing is welded to that stringer. And let me open up another example. I think this is column. And you can see here on both sides these stiffeners that were welded, and then here on both sides a gusset plate. Okay, so that is a bit more about the STV files and those contours, of course. And it's important to decide, of course, if you want those contours or not. Then the next thing I'd like to show you is some more about general arrangement drawings. So let's start with inserting the first view. So this is the easiest way to start adding views. So let's just add a view for the ground floor. There are three ways to, three or even four ways to draw views. So this is the first way, first method. And the second method is using this existing view. So if you use this command here, draw section, and just click, and then choose the direction and the depth. So, and then the position for the new view. So this is the view on grid 1. So that is one other way to draw views. Another way to draw views is, of course, just detail command here. So if I would like to zoom in on this one. So this will create a boxed view. Now, I've told you that before, properties are very important because there are a lot of tools available from them. And if I select properties for a view, you can see here we have the camera options. So I'd like to show the handrail in this view. So I can just say view limitation front is okay, but the back, I would like to see more. So I'm going to say 1.5 meters. And after such a change, I need to refresh this view to see the change. So the view is quickly generated, and then you can see that it has drawn the railing. Another thing that we can do inside the properties is scaling, of course. So this is an additional scaling for this view, but we have other tools like invisible model lines. You can enable that, but you will need to refresh the view for such a change. So now you can see the plate behind there. So one thing I'd like to add is each view is usually linked to a camera. So I haven't been drawing camera, but the commands will do that automatically for me inside those commands. So as you can see here, 3 cameras were created, a details section. So I can just right click and then say zoom in on that camera. And then it will go back to the 3D model, zoom in on that camera. And here you could, I don't know, move the camera or something, or you could stretch it. So if you take one of the grip lines and stretch it. So that's one thing you could do in 3D. And then if I go back to that detail on the sheet, the change is not done automatically. You need to refresh the view. And then you can see the change to that. Also, if you want to apply annotations after the view was done, you can do that with a tool here. Select the view and then choose which annotations you would like, and it'll add those. One other thing I'd like to show, let's say in this section view, I only want the railing to be visible and all the others should be hidden. So that's also a possibility. We can just go to section 1 in the model, and here you can see I'd like to select this railing and say that that's the only thing that should be shown inside that view. So let me enable the assembly selection. Okay, and then I'm going to this property here, included parts. So if I click that and I say only include the railing, you can already see that I have selected 87 parts. So if I go back to the 2D sheet and I refresh this view, then we should see the change. So that's one way to hide parts, but maybe not always the best way. Because the disadvantage of this, maybe after a change, we have added a new post or something, or added a new part to this, then that new part might not be included because we have filtered on a selection. So that's not necessarily the best tool. There is another way to do the same. So for example, let's generate a new view, and I'm going to choose current view. So current view really means the current view in the 3D model space. So if I do that, then I should see a view of my 3D direction. Yeah, so that's what I had been looking at. Okay, so this view is now too large for the page. We can just right click and change scaling to fix that, for example. Or we could change the scale of that view, of course. That would be a solution as well. And now I'm going to open up the layers status dialog box for this view only. And here I'm going to disable layer 0. So for this view, I'm actually disabling all 3D models because I haven't been using layers at all. So it's just a way of filtering all of the parts in the views. So if you use layers, then that would be a better solution than to use the inclusion or exclusion tool of the camera, because the layer is more permanent than a selection. Okay, so we've seen the link between the 3D camera and the 2D view. I think I have shown everything that I wanted to show for the documentations. There is one thing I'd like to still show is here we have Bim Export. That's an important command. So if you use that with IFC 2x3, you can export all of your 3D model data that can be read in other CAD programs, but like Revit, for example. But there is also this tool, and this is a very good tool if you need to send your drawing to someone that has AutoCAD or BricsCAD but does not have a Parabuild. Then this is the tool to use, because it will also export all the 3D models, and each plate and bolt will be shown as a 3D solid, so that it will be browsable. And even the position and the part numbers will be attached to each 3D solid in that drawing. And the same tool is available for importing, so IFC or CIS2. So that is, these tools will import the IFC and generate profiles, plates, and bolts from that file. So that's also a very important tool these days.
That concludes this live demo recording. Thanks for watching, and for more information, please visit our website at parabuild.com. There's a free trial available.